Coming up next, we are going to be learning how to model the universe in 3D in a browser. Modeling the universe in 3D. Wow. This is going to be interesting. 3D, all the rage these days. Modeling the universe 3D in a browser. We've got Greg on the mic. Greg, are you all set up and ready to go?
I hope so.
All right, here we go.
Thank you. So actually, this is going to be a bit less of a how-to than kind of the journey. We will step back in time. And by the way, this is like the lowest tech slides ever. It's just a single web page, and I apologize for that. We'll start by going back to my childhood. I was the proverbial child of the space age. When I was growing up, we were shooting people into space. Every few months, and not just this low Earth orbit namby-pamby crap, but to another world, right? And not just flying around it; they were walking on it, right? Leaving footprints and garbage behind. It was pretty cool stuff. And that's actually the first memory I have of the external world outside of school and home, and so that was just something that we did. Simultaneously, we had some television series, science fiction, Lost in Space, Outer Limits, the first couple of Star Trek series. And a common theme through many of these was travel to other stars. And it was cool. And it was obvious that traveling to other stars, it was 3D space, right? You could go in any direction. And clearly they had 3D star maps. But I didn't, all right? So, and also, I wasn't going with them, which also irritated me. But I really felt the lack of an ability to understand, where they were going, what they were doing. Talking about stars, even ones that are in our sky, but we can see only as dots on a two-dimensional sphere, was not helpful. So a dream growing up was to actually build a 3D model of our local stellar neighborhood in my room. Well, time and practicality and lack of data kind of torpedoed that idea. But fast forward a couple of decades, in the late 90s, PCs had already been cheap for a long time, but the 3D accelerated hardware was also finally getting cheap. And people started taking notice of this. Companies beyond the gaming companies that had driven the low costs were getting dollar signs in their eyes and thinking, gosh, we can have really, really annoying ads popping up in people's faces now. So among other things, they started working on a file format, something sort of like HTML except in 3D, called VRML, the Virtual Reality Modeling Language. 1997, that became an international standard. A bunch of companies were simultaneously making browser plugins. So suddenly we had the tools to do virtual worlds in kind of local machines. And of course, okay. So with VRML, you could start to do things like this, and people did. As an aside, those of you moving into 950 or 1000 mod will become very familiar with this particular architecture. And they could do things like this, animation. So it was doable. And this is just a GIF animation, by the way. This is not the actual VRML. So that was great. We had the toolkit finally, but the data sets were still missing. The internet was not quite what it is today. There was a lot of stuff on it, but the scientific data sets, a lot of the published stuff was still kind of, if available electronically at all, it was word of mouth, FTP sites, hard to find. So fast forward another decade and a half. In 2011, some nice folks at a project called the 2-micron all-sky survey, 2 microns being 20,000 angstroms. That's the far infrared. It's important because it's a wavelength of light that's able to penetrate the dust and gas that's in our galaxy, which means we can see outside our galaxy and not be blocked by things like the Milky Way, as we saw in the last talk. So they finally published this data, and the cool thing about it was it included redshifts, which you can turn directly into radial distance, and suddenly you could do stuff like this, and literally 4 hours after grabbing the data set, I had my first model in Vermal, and yeah, it was exciting. It was even better on a big screen. I mean, this is like 400 pixels across, but you could display it full screen, and so over the following year, I'm sorry, yes. Excellent question. So yes, the gap in there, the zone of exclusion, that's the plane of our galaxy. The infrared light has magical properties with respect to dust, but it's not like infinitely powerful. And looking directly through the plane, you can't see anything but stars and stuff. So anyway, had this nice data set, had this model over the next year or so, underwent more than a dozen major additions and refinements. And it eventually became a very nice, elegant bit of work from the perspective of kind of software craftsmanship. So this is my nod to the craft theme here. You can see a lot of different components, optional and otherwise. Not sure why the left edge is cut off, but it doesn't really matter. Dual coordinate systems, Earth-centric, we're spinning around, but turns out if this is the plane of the galaxy, Earth's orbit is about 60 degrees to that. So, and we like to do a lot of things in galactic coordinate system. So I was able to add extra data sets, add and subtract easily, have variants that would either rotate or not rotate that included more or less data. From a software perspective, this was, nice work. The problem was, what I would maybe call the zeroth law of craftsmanship. You could not share it, right? By this time, Vermal browsers were long gone. I think the people that originally put up the data set, I managed to get them a binary copy of a Mac browser before it disappeared. But otherwise, the only people who ever saw this were those who came to my house and looked at my machine. And even at home, only one of my machines was capable of doing this stuff. So there we stood for another couple of years. Last year, started hearing a lot about something called WebGL, which is accelerated 3D in the browser. And yeah, something also called three.js, which finally allowed me to start building things that are shareable. This URL, by the way, anybody can go to, anybody with a WebGL-capable browser, which is most of the modern ones. And, lo and behold, it's not the same as Vermal, but, 3D is 3D, and you can generally do similar kinds of things. So with this proof of concept under my belt, this, by the way, was a hike our team did a few months ago, data captured by a GPS device. I started reworking the universe code. And I'm sorry, I knew this was going to be an issue the moment I heard outdoor tent. It's really bright, and I encourage everybody to wander on up here, even right now, if you can't see it very well. But started converting the model of the universe into the three.js browsable version. And you can see right now we're flying through a bunch of color-coded galaxies. These are color-coded in terms of distance. We're coming down to our local group of galaxies. That's our galaxy cluster. Again, they're color-coded. The pink ones are the Andromeda Galaxy and its satellites. We've got the Milky Way and its satellites in orange. Ones that aren't explicitly satellites of either one in green. Some textures, some other nearby galaxies pointed out. So, suddenly I had something that I could easily share, and unfortunately we're a little little bit of performance issue there. But that was the end goal. So since then, I've discovered some additional data sets, learned how to add some controls to enable or disable the animations. The red cloud down here is a set of 870 or so nearby galaxies that some folks in Russia measured distances to, and you can see they're all labeled, and we come in, can zoom, rotate at will. And this is just a start. I mean, I've literally been doing this on a few of the weekends over the last 3 months. I've got a lot more to go, but finally I can share things. Finally, my craft is out there for other people to see. So, thank you.